Hello, tech enthusiasts, and welcome to our new series, Kubernetes Cost Mastery AIOps-Driven Strategies. I'm Nilay, your guide on this explorative journey where we will dive deep into Kubernetes, uncovering how artificial intelligence in operations, or what we know as AIOps, can dramatically enhance cost efficiency and system performance. As we navigate through this complexity, our series aims to provide you actionable insight and strategies. Whether you are an experienced DevOps professional or just starting out, this series will offer valuable knowledge to optimize your environment effectively. Today, in our first episode, which is titled as a foundation of efficiency, we will lay the groundwork for understanding the basics of AIOps in Kubernetes context. We will explore how integrating AI and machine learning technique can lead to smarter resource utilization, enhancing scaling strategies, and ultimately cost-effective solutions. Our journey will not just be theoretical, but we will conduct some real-world experiments, simulations to bring some sort of a tangible data-driven insight. So whether you're looking to fine-tune your existing setup or build the new one from the ground up, this series is going to be resourceful in order to get better Kubernetes AIOps. Stay with me as we embark on this journey together. And get ready to transform the way you manage your Kubernetes with AIOps-driven strategies. As we dive into the heart of our series, it's crucial to outline what we will be covering in the coming episodes. Our focus will be on the intersection of Kubernetes and AIOps, a cutting-edge approach that leverages artificial intelligence to optimize and automate operations. First up, let's try to understand what is AIOps. AIOps stands for Artificial Intelligence for IT Operations. It's about using machine learning and data science to solve operational problems, predict issues before they happen proactively, and automate the responses to the real-time events. The next thing, we will also dive into resource utilization monitoring with AIOps. Here, we will explore how AIOps provide deeper insight into resource usage. This is not just about tracking. It's about predictive analysis and anomaly detection, allowing for many predictive measures while we are having resource management at our hands. Then we will discuss AI-enhanced scaling strategies. Kubernetes is well known for its scalability, but how do we optimize it? We will look at some machine learning-driven approaches that balance performance, cost, ensuring efficient resource allocation and management. And finally, smart pod clustering, auto-scaling. We will integrate AIOps with Kubernetes auto-scaling mechanism like HPA, horizontal pod autoscaler, or VPA, vertical pod autoscaling. We will also touch upon the proximity analysis and other advanced techniques to achieve cost-effective scalability. In this first episode, we are setting the stage for a broader overview. Let's call it 60,000 feet overview of these concepts. And we progress through the series. We will take a deep dive into each topic in the coming episodes. We will unpack them with practical, hands-on, and real-world application. Whether you are a seasoned Kubernetes user or are new to this AIOps and Kubernetes, the goal of the series is to equip you with the knowledge and strategy to take forward from wherever we are starting into effectively through power of AIOps. So let's get started. Dive into this interesting world of Kubernetes and AIOps together. Let's dive into the practical aspect now. And a very important one: experiment. To truly understand the impact of AI ops on Kubernetes, we conducted a comprehensive experiment based on the real world scenarios, synthesizing data to mimic the actual development and production environment and also the AI model training. Our experiment spanned over 9 months, incorporating a lot of real system data. This includes many seasonality factors, feature variations, and a lot more. We meticulously generated this data in a lab setting to cover the wide array of edge cases, drawing from various experiments and experiences. We didn't stop at the data generation. To validate our strategy, we ran an optimization script and models against the real world data. This approach allows us not to test effectiveness of our methodologies, but to ensure they are applicable in the real operational environment. This experiment was pivotal. It's not just about proving the theories, but it's about demonstrating how practical and actionable insight can be generated. As we go through our series, we will refer back to this experiment using a benchmarking measure for effectiveness of various AI strategies in Kubernetes environment. Think of this as like our testing ground, a place where theories meet practice. The insight we have gained here are quite invaluable in my opinion, proving us with solid foundation to discuss and demonstrate the true power of AI ops in such environments. Stay tuned as we discuss these results in the upcoming chapters and videos, translating the complex data into understandable, actionable strategies. We are not just talking about theoretical possibilities here, we are also going to showcase the tangible and proven solution. Now let's see the architecture that underpins our Kubernetes and AIOps integration. Understanding this framework is very crucial, in my opinion, for for seeing how we have optimized the capacity of computing environment using both planned and adaptive methods. Here is an overview of our architecture. The cornerstone of our data collection process, or SRE, and SRE practices applies software engineering principles to operation. This is where we gather operational data essential for our analysis. Next, we have a Kubernetes telemetry. This includes matrices, events, log from Kubernetes cluster, nodes, pods, container. It's vital for understanding the health and behavior of our system. Similarly, the application telemetry gives us insight into performance of application running on Kubernetes, especially for quality of service benchmarks, which is quite crucial to establish whether the optimization strategy is proving to be positive or negative, and how the impact can be understood from the application performance. Prometheus plays very key role here. It's a monitoring tool that collects and stores telemetry data using a pull-based method for scraping data at regular interval. However, it is also important to understand that Prometheus comes with one limitation, and that is data retention. For a long-term storage, we have used Grafana Mimir, or alternatively, Thanos can be also considered as a very good alternative candidate, which extend the power of Prometheus for historical data. Lastly, the AIOps data science component, where we apply data science techniques to the operational data, helping us in planning, forecasting, decision making, and it is a critical part of achieving optimized capacity in our computing environments. This architecture isn't just a theoretical model, it's a quite practical in our understanding, and we have tested this particular setup with many use cases before. It represents the backbone of our approach to the cost effective and scalable solutions. In this chapter, we are going to focus on a crucial aspect of our AIOps journey: the data. Understanding what kind of data to capture and how to utilize it effectively is the key to optimizing any environment using AIOps. In the world of Kubernetes and AIOps, the data we capture can be incredibly diverse. For our purpose, though, we have streamlined our focus to primarily around CPU and memory use case. While the real world scenarios or the use cases offer much complex array of data types, we have chosen to keep our data set approachable yet robust enough for meaningful analysis during this series. Our experiment data is segmented into three phases. The first set of data, where the environment was without optimization, post the first phase optimization, then following the second phase optimization. This segmentation allows us to clearly illustrate the impact of our optimization strategies at each stage. Capturing data across this segment help us to paint some insightful picture from the baseline unoptimized state through the iterative optimization process. We can observe the tangible benefits, improvements brought about by our AI ops strategies. This data isn't just numbers and graphs, they represent the real Kubernetes behind the scenes or behind the curtain environments. By examining them thoroughly, the lens we gain is not just how we make our system more efficient, but how we drive them towards the peak performance. As we dive deeper into our series, we will use this data to explore, analyze, and demonstrate practical use cases benefiting in AIOps. So stay tuned around there. We will look for hidden gems within this data that we have captured. Welcome to the new chapter in our series, Exploratory Data Analysis, or well known as EDA. This is where we dive into heart of our data, unrevealing the story that we found so far. It tells about the Kubernetes performance and efficiency. So let's start look into it. Especially let's start with the CPU usage. We are looking at the detailed plots that show how CPU usage varies across the different stage of optimization, before, during, after. Notice the patterns that emerging as we apply AIOps-driven strategies. Next, we analyze the compute node cycles over the week and a month. This helps us to understand how Kubernetes environment respond to the workload changes over a period of time, particularly in response to our optimization efforts. The quality of service or QoS metrics, especially the application response time, provides us a good insight into user experience. Coupled with the cost per hour data, we get a clear picture of the financial impact of our optimization. For a detailed view, we repeat this analysis for each experiment phase, whether it's unoptimized, first optimization, the second optimization attempt. This comparative approach allows us to measure the effectiveness of each strategy quantitatively. Look at this table comparing the pre-optimization and post-optimization phases. It clearly shows the improvement in average response time, um, subjective, uh, processing time across the different application, cost per hour, cost per month overall. Matrices notably decreased, showcasing the financial benefit over optimizations. This is not I would say just a numbers. It tells us the story and the power of AI ops, especially with the complex setups such as Kubernetes. By the end of this series, you will have much detailed understanding of how to analyze and interpret such data to drive your own cost efficient strategies. As we progress through our series, we will break down this finding much further, exploring how each element contribute to more cost efficient and high performing Kubernetes environment. Anomaly detection is a critical component in AIOps, especially when managing complex systems like Kubernetes. In this particular chapter, we will explore how identifying and addressing anomalies can drastically improve system performance and efficiency. We have chosen isolation forest algorithm for our experiment. It is uniquely suited for detecting outliers in our data, which could indicate potential issues. This approach isolates anomalies instead of profiling normal data points and making it highly effective in diverse environment. While isolation forest is the primary experiment and the algorithm of our choice for this particular demonstration and series, but there are much powerful algorithms can be employed as well, like dbscan, k-means, autoencoders. Autoencoders could be very highly effective in many use cases where the complexity of data and the feature extraction and grouping them by feature could be very useful. And they all can be employed in a mix and match for anomaly detection to scope out any false positives. Each has their own strength, and choice depends on specific scenario and data characteristic. Unfortunately, we won't be able to cover in detail about each and every algorithms, but this should lead you towards the thought process that is essential for deciding or a one or a group of algorithms. By applying this kind of a detection to our Kubernetes telemetry data, we have enabling the pinpoint areas that required our attention. This is not just about finding faults, it is about the proactive system management, identifying anomalies early that leads to faster resolution and maintenance, enhancing overall system health and performance. The benefit of anomaly detection in AI extend beyond simple troubleshooting. It paves the way for predictive maintenance, capacity planning, and even informed scaling decisions. Integrating these capabilities into your Kubernetes strategy will certainly ensure more resilience and cost-effective system. We will deep dive how anomaly detection can be seamlessly integrated into AI ops for Kubernetes in the coming chapters. And we will also walk through some sort of real world examples and practical applications of it. In this chapter, we will dive into the world of predictive analysis within AI ops. Predictive analysis is a game changer, especially in the dynamic environments such as Kubernetes, where anticipating future trends and behavior can significantly enhance your operational efficiency. We use tools like Pairplot for internal exploratory data analysis. It helps us to understand the relationship between different variables in our environment. Especially Pairplot with the capability to visualize data in multiple dimensions and Cartesians is very instrumental to understand the early and initial trends and potential areas of optimization. Alongside, we are using random forest regressor, which is a quite high accuracy regression task in machine learning model. It's well known for this. It's particularly good to adapt handling non-linear relationship in large data set, making it a very valuable tool for predictive analysis. Of course, the random forest regression is not the only algorithm to be considered. It very much depends on scenarios. Another algorithm like linear regression, gradient boosting, especially XGBoost, and maybe neural networks as well for a self-learning. If you got very intricate patterns to be discovered, which is difficult with the basic machine learning models, then deep learning or neural networks would be very useful. And very much the choice hinges on the specific characteristic, the problem, and the requirement of data itself at your hand. The beauty of this predictive analysis in AIOps lies its ability into the future state forecast. This forecast enables us to make informed decisions, certainly, ensuring optimal resource allocation, cost savings, enhanced system performance. As we move into our series forward, we will dive deep into predictive analysis component into coming episodes, which can be effectively integrated into day-to-day as well as quarterly Kubernetes operations and housekeeping. Uh, it demonstrates the real-world benefits. So stay tuned for more in-depth discussion insight in our upcoming chapters. As we wrap up our first episode in Kubernetes Cost Mastery AIOps-Driven Strategies, this series of 4 videos, I want to thank you for joining us on this insightful journey. Today, we have set the foundation of understanding how AIOps can revolutionize the Kubernetes efficiency. We begin by exploring the basics of AIOps and how it intersects with Kubernetes. We then dived into real-world experiments showcasing the power of data-driven strategies. From architecture to exploratory data analysis, we covered the important pillars that will drive our future discussions. As the journey has begun, in the upcoming episodes, we will deep dive into each of these individual topics, explaining more complex strategies and practical applications. Whether you are a Kubernetes expert or a beginner, our series aim to provide you some valuable insight to master or to better your Kubernetes skills around the cost effectiveness. If you found this episode informative, please make sure to subscribe to our YouTube channel, stay connected for more episodes, and don't forget to join our discussions on LinkedIn and Twitter. Your engagement and feedback fuel our journey forward. So until next time, keep exploring and optimizing. Thank you.